So I've done the first two already. And you can see in the first one I did sine x equals sine theta, dx equals cosine d theta. Plugged it in, and I end up with cosine squared. Use the half angle trig identity to switch it to this. Then integrated it, and then used this rectangle to switch back to that. So take your time and look that through, make sure it makes sense. Okay, then this one I did x equals sine theta, dx equals cosine theta d theta. And again, make my substitutions here, and it ended up being cosine squared over sine, which is not a nice thing because they're derivative of each other, but the cosine squared messes with me. So I switched the cosine squared to 1 minus sine squared, and then got this. And the way, and of course the integral of sine is cosine, but the way I got this log expression is similar to what we've done with secant in the past, where we multiply top and bottom by, so that we get kind of a du over u here, except for this should be a negative, so it's really like a negative du over u. So that's why we got a negative ln there. Okay, so that's the first two, and then I'll walk us through the next two. All right. Number 3, we're going to do, look, it's x squared minus 9, so that makes you think of secant. So I'm going to let x equal 3 secant theta, which means dx is equal to 3 secant theta tangent theta, d theta. So then when I make my substitutions in, essentially the square root becomes tangent, and on the bottom I'm going to have becomes 3 tangent, and on the bottom I'm going to have 9 secant squared theta, and then replace the dx with 3 secant theta tangent theta d theta. Okay, so one of the secants cancels with one of the secants below, and the tangents combine, and actually the 3 and the 3 cancel out the 9. So I end up with tangent squared theta on top and 1 secant theta on the bottom, d theta. And that's not very nice. It would be nice if it was the other way around, wouldn't it? If we had tangent on the bottom, secant squared on the top, then it'd be a du over u. But we don't have that, so let's change everything to sine and cosine. So this would be the integral of, let's see, that'd be sine squared theta over cosine squared theta. And then secant, 1 over secant is the same thing as cosine. Okay, so the cosines canceled out, and I'm left with the integral of sine squared theta over cosine theta d theta. And that's similar to the thing we had up here, but it's cosine squared on top, so we're going to use a similar move. So this is going to be equal to the integral of 1 minus cosine squared over cosine. So we can break it apart into 2 fractions, and we get the integral of secant theta minus the integral of cosine theta, d theta in both cases. And this is going to be similar to that last move. We're going to have the natural log of secant theta plus tangent theta, and that's going to be just sine theta plus c. Okay. Number 4, we got x squared plus 16. That makes me think of tangent. So I'm going to have x is equal to 4 tangent theta, which means dx is equal to 4 secant squared theta. And so my integral becomes, well, okay, again, when we put the tangent squared in there, we end up with 16 secant squared, and when we square root it, we get 4 secant theta d theta, which is 4 secant squared theta d theta. And then on the bottom, we have x to the fourth, which would be, what, 64 tangent to the fourth theta. Okay. And looks like a couple 4's will cancel out. That would be, whoops, that's 4 to the third, isn't it? So this is actually, will be 4 to the fourth. 2 of those 4's cancel out, leaving just a 16 on the bottom. So I'm going to have a 1/16 out front, integral of secant cubed theta over tangent to the fourth theta, d theta. Now, if we, again, this is not, if it was secant squared, we would be in good shape right now. But it's not. So I think our next move would change everything to sine and cosine again. So that would be the integral of, and secant is 1 over cosine, so that would be 1 over cosine cubed theta times, and tangent is sine over cosine, but we're flipping it, so that'd be cosine to the fourth over sine to the fourth. And 3 of those cosines will cancel out. So we're ended up with the integral of cosine theta on top and sine to the fourth theta on the bottom, d theta. And this is a classic opportunity for u substitution, because we could say that u equals sine of theta, and therefore du is equal to cosine of theta, d theta. And so then this is really just the integral of du, or sorry, u to the negative 4 du. So that's going to be equal to 1/3 negative u to the negative 3 plus c. Now we've got to do a series of substitutions to get back to where we're supposed to be. So that would be negative 1/3 sine to the negative 3 theta plus c. But then sine, so we need a triangle. Here's my triangle. Here's my theta. And we had tangent is x squared plus, I'm sorry, tangent is x over 4. So that'd be x and 4, which means this is going to be the square root of x squared plus 16. So that means sine would be x over the square root. So we're going to rewrite this as negative 1/3. And I'm just going to flip the fraction over, so I don't have to do the negative exponent anymore. So this would be to the third power. And sine would be x over the square root, so we'll flip that over. So you have the square root of x squared plus 16 over x, and then plus c. Okay, and let's see, ooh, this is a fun one. So we got x squared minus 4, that's going to be a secant, so we'll let x equal 2 secant theta. And therefore dx is equal to 2 secant theta tangent theta d theta. And that would be, let's see, so the integral is going to be x cubed, which would be 8 secant cubed theta. And then on the inside here, we're going to have 4 secant squared theta minus 4 to the 5/2 power times dx, which is 2 secant theta tangent theta d theta. Okay? Now this 4 squared secant squared theta minus 4 becomes just a 4 tangent squared. And then, of course, that square root and the square root will cancel out. So this would give me 8 secant cubed theta times 2 tangent squared theta. I'm sorry, 2 tangent theta to the 5th power times 2 secant theta tangent theta d theta. Okay, so let's consolidate everything. So we have the integral, and we have a 2 to the 5th, and there's another 2, so that's 32 times 2 is 64, so 8 times 64, 512. And let's see, how many secants do we do? We have secant to the 4th, and we have tangent to the 6th d theta. So if we pull out secant squared for the du, we're going to end up with 512, the integral of u squared plus 1. So that'd be u squared plus 1 times u to the 6th du. If we're letting u equal secant, or tangent, we're letting u equal tangent, and therefore we pull out a secant squared as part of the du. Okay, so then in the end we're going to have 512 times, so that's u squared times u to the 6th is u to the 8th, so that'd be u to the 9th with a 1/9 out front, and that would be u to the 6th, so that'd be 1/7 u to the 7th plus c. So now we got to fix that. 512 times 1/9 to the of what was u? U is tangent, so that'd be tangent to the 9th theta plus 1/7 tangent to the 7th theta. And remember, tangent is, well, we need a triangle again. Do our little triangle here. Theta, secant theta is x over 2. So that would be x over 2. And this is going to be the square root of x squared minus 4. So that means that tangent is going to be the square root of that over 2. Okay, so that'll make this interesting. So that's going to be 512 times, on top, we would have, yeah, I'm not going to do that. Let's do 1/9 times the square root of x squared minus 4 over 2 to the 9th plus 1/7 times the square root of x squared, the square root of x squared minus 4 over 2 to the 7th plus c. And for number 6, we get a nice easy one. That's just arc sine with a 9 thrown in. So we would rewrite this as, we pull out a 1/3, and that leaves us, actually we can pull out a 2/3. And that leaves us with 1 on top, dx, and the square root of 1 minus x over 3 squared. And when I look at that, that looks like arc sine. So that would be 2/3 arc sine of x over 3. And if we take the derivative of that, it's going to, derivative of arc sine x over 3 will be just that with an extra 1/3 kicked out. So we don't want that, we don't need that third there, so we can just put a 2. All right. That one's pretty easy. Plus c, of course.